Hi guys, it's Talha here again. So yesterday I didn't make a video because I was a little busy, but today I decided to make a video, and we are again going to talk about calculus. We are going to talk about trigonometric functions again, trigonometric functions, and then I'm going to tell you the unit circle definition, unit circle definition of these functions, and then if you have time, I'm going to tell you how to graph these functions, or if you have time, I'm just going to tell you how to graph the function of sine. So let's first discuss some let's just recall what were trigonometric functions. So trigonometric functions are the functions which are related to a triangle here, which are related to a triangle, and it's just the study of the ratios of the sides of the triangle. So we have three basic trigonometric functions, which are we have sine, we have cosine, cos, we have tangent, tan. So these are the three basic functions, trigonometric functions, of the ratios of the sides of the triangle. So let's consider that we have a right angle triangle right here. So we have a right angle triangle, and uh, the amazing mnemonic I learned from Khan Academy was so ka toa. So this, I think, is the most basic and the most easiest mnemonic you can ever learn, and it's going to help you a lot, trust me, because it helped me a lot as well. So let's say that we have theta here. We have theta, and this side is h. This side is h. This is o, means that this is opposite, and this is a, means this is adjacent. So what does sine tells us? So sine tells us so that means o, that means o divided by h. So that means opposite to the angle divided by hypotenuse. So we can write sine equals opposite divided by hypotenuse. This is sine. Now what does cos tells us? Ka. So ka toa. So ka means a means adjacent, so cos equals a means adjacent, which is this side. So adjacent divided by h, which is hypotenuse. Now tangent theta is equal to, which is toa. So, or you can say toa. So toa. So opposite divided by adjacent. So opposite, we have o divided by a. Or if you want to tangent theta is also equal to sine theta divided by cos theta. So if you divide tangent theta equals o by h divided by a by h. So what is going to give you? You're going to, this implies o by h into, and the terms are going to reverse, or h by a. So h is going to cancel out. It's going to give you o by a, which is right here. So these are the basic trigonometric functions you guys need to remember, because in the future study, when we're going to study these trigonometric functions, the more complex trigonometric functions, these functions are the base. So it's going to help you a lot if you know these functions. It's going to surely help you. So these were trigonometric functions. Now let's see the unit circle definition of these trigonometric functions. So for example, I have a unit circle here. I have a unit circle, which and a unit circle means that its radius is 1. So it has 1 as its radius. I'm sorry, it, it does not look like a circle. but still. All right, so this is a circle, and let's say that this is the angle theta. This is the angle theta, and here this side and this side here, the hypotenuse is actually equal to 1, because it's actually the radius of the circle. Here we have this side, we can say that this is x, and this side we can say that is y, because it's on the y-axis, and this side is on the x-axis. So now let's find the sine of this angle, or the sine of this theta. So we have sine equals opposite, so y divided by h, which is the hypotenuse, and hypotenuse is 1, so we can say that sine theta equals y. This is an important term, and you guys should pay a lot of attention to these kind of formulas, because they're simple, but they help you a lot when you study on a higher level. So now let's do the cos. So cos theta is equal to adjacent divided by hypotenuse. We have adjacent as x divided by hypotenuse, that is 1, so cos theta equals x. This is the second one. And now let's find our tangent, and tangent is opposite divided by adjacent. So we have opposite side y divided by x, so we have y divided by x, or as I explained earlier, tangent theta is also equal to sine by cos. So this was the unit circle definition of these trigonometric functions. So for example, if we have a point here, that is or here, so okay, so this is the point which is 1, 0. So it has an x coordinate of 1 and a y coordinate of 0. So what's going to be its sine? What's going to be the sine of theta? So we have, as we just discovered that sine theta is always equal to y. So here, what is y? Y is 0. So that means if this point is 1, 0, if x is 1 and y is 0, so that means no, sorry, this point is 0, 1, because x is 0. No, this point is y is 0, and no, x is 0. Okay, here, sorry, this point. Okay, so if I say that this point, so here what we have is x is 1 and y is 0. So on this point, if you consider a triangle on this point, so let's find the sine of this theta. So we have sine theta, as we discovered that sine theta is equal to y, so we have y we have the y coordinate as 0, so sine theta of this point will be 0, because we just discovered that sine theta equals y. And what's going to be the cos? So cos theta equals x, and x coordinate here is 1. So that means that the cos theta of this angle at point 1, 0, that means when x is 1 and y is 0, so its sine is going to be 0 and its cos is going to be 1. Let's say the point is right here. So that means it's approaching 90 degrees. So what is its tan going to be? So we have y, for example, this is 1, so we have y tan theta equals y, we have y1 and x0, and anything divided by 0 is undefined. So tan theta is undefined at when you have x equals 0. So that means here, so here you have 0, 1. So that means sine equals 0. Oh, sorry, sine equals 1 and cos equals the x coordinate, that is 0. So that makes tan theta undefined. But if you calculate the sine over here, you have a sine equals 1, sine theta equals 1, and if you calculate the cos over here, you have cos theta equals 0. So this was the unit circle definition of these trigonometric functions. Let's discuss some of the formulas, or some of the identities of these trigonometric functions. So let's consider I have the same triangle. Let's consider I have the same, or I have a unit circle. I have a unit circle over here. I have a unit circle whose radius is 1. So if I draw a triangle over here, so this radius is 1, and this is a right angle triangle, and let's say this is the cos theta, that is x, and this is the sine theta, that is y, and this is 1. So what is Pythagorean theorem tells us that hypotenuse equals perpendicular square plus base square. So let's apply this formula over here. So we'll get 1 whole square equals perpendicular, that is sine theta square plus cos theta square. So what that actually gives us, it gives us sine square theta plus cos square theta equals 1. So this is an identity for sine square theta plus cos theta square theta equals 1. Now let's find some more identities through this one. So what we are going to do, let's divide these this here right here, this right here, and also this by cos square theta. So it's actually going to give you 1, and here sine square theta divided by cos square theta logically, and it's of course tan square theta plus 1 equals 1 by cos square theta, and we know this 1 by cos square theta equals secant square theta. So tan square theta plus 1 equals secant square theta. So this is the second identity of your trigonometric functions we just derived. So there are many other identities you can derive through either this one right here, or you can also derive through this one right here. So let's now discuss okay, so we have time. Let's now discuss how to graph trigonometric functions. So for today's video, I'm just going to discuss how to graph the function of sine. So as you guys remember, in the earlier videos I told you guys, for the graph of any function, first you gotta have the values for the domain and the range. Same is the case here. So if you want to find the value for sine theta, so let's say that so here is the graph, and here, okay, so what we do, for the units of measurement, and for instead of writing 1 2 3 4 5, what we actually do, we write pi, we write here, we write I guess, so this can be pi by 2, this can be pi, and here this can be minus pi by 2, can be pi, and right here you can do here, and this can be 1 2 3, so minus 1 minus 2 minus 3. Alright, so for sine of theta, when you put x as when you put x as 0, so sine of 0 equals, as we discussed earlier, sine of 0 equals 0. So you have sine of 0, y equals 0. When you put sine equals pi by 2, when x equals pi by 2, you have sine equals sine of pi by 2 equals 1. So you have 1. Then again, sine of pi equals 0, sine of pi equals 0, sine of pi equals 0. So what it does, it actually repeats, or it's a periodic function. So what are periodic functions? Periodic functions are the functions which repeat, which for example, you have you have a graph of the function, and it repeats as it goes along the x-axis, and it goes along the through the negative x-axis. So what it does, it actually repeats. So functions which repeats after some interval of time, that function what we call is called periodic function. Or you can also say that, for example, you add some constant, or you add sine theta plus 2 pi. So what is 2 pi? 2 pi is just the circumference of the circle, and after plus, if you add 2 pi, the function is going to be the same. There will be no difference. So sine theta plus 2 pi equals sine theta itself. So when you have this case where you add a constant and it gives you the function, it gives you the same functions, so this kind of function is called a periodic function. So so let's actually graph this function. So you add 0, you have y equals at x equals 0, you have y equals 0. At x equals pi by 2, you have this y equals you have y equals 1. Alright, and at pi it again becomes 0. It again becomes 0, and it goes like this. It goes like, in a period like this. And same here. Same here. So what this function is, it's actually a periodic function which repeats. So the period here, so from here to here, we actually have 2 pi, because this is pi, here right here is 2 pi. So here from here to here, so this graph is actually repeating along the x-axis. So we have this as its period, and how much is this? This is actually 2 pi. So 2 pi is its period, and the amplitude, its height from origin to the positive y-axis, and from the origin to the negative x-axis, to the negative y-axis, it's actually 1. So you have period of a sine function as 2 pi, and the amplitude is 1. So these are the two important terms to consider, and this is actually the graph of sine functions. And what's the graph of a cosine function is going to be? So the graph of the cosine function, so when you put 0 in a cosine function, it gives you 1. When you put pi by 2, it actually gives you 0. So what it's actually going to be, it's actually going to be like this, because at 0 it gives you 1, at pi by 2, at pi by no at 0 it gives you 1, and at pi by 2 it gives you pi by 2 it gives you 0. I've drawn this graph. It's pretty messy, so you guys won't understand, but you guys get the idea that cos and sine functions are just cos is a little shifted towards the left side, and sine, it is because and the most important differentiation you guys can do is by looking at is by looking that what answer or what range of y does the function gives you when you plot the point, or when you find, or when you put the point 0 into the function. So for sine equals 0 you get 0, and for cos equals 0 you get 1. So that's the differentiation which you guys can do. And also I'm short on time, so thank you guys. I hope you guys liked my lecture, and I hope it helps. Thank you very much.